This is Suryam, Assistant Professor, Department of Pharmaceutics, Vishnu Institute of Pharmaceutical Education and Research, Narsapur. Today, we will discuss about the colloidal dispersion, especially the following contents. Like first, we will discuss about the colloids, definition of colloids and dispersion systems and the classification of the dispersion system, classification of the colloids, or you can say the types of colloids. Craft point, we'll discuss about the craft point and the various applications of the colloids. So let us start the class about the colloids. And so generally colloids, this word meaning from the Greek is, it is a glue like substance. That means it is a gum. And the colloids are dispersions where in dispersed particles are distributed uniformly in the dispersion medium. By reading this, we can understand these colloids will be containing two different phases, that is dispersion phase, dispersion medium. Coming to the definition of colloidal system, are defined as those polyphasic system. Polyphasic is also known as biphasic system, where at least one dimension of the dispersed phase and measures in micrometers is also known as colloids. And we have another definition of the colloids here. These are the heterogeneous mixture. Yes, it is a heterogeneous mixture. How it is a heterogeneous mixture? Because we have two different phases, dispersion phase and dispersion medium. That is the reason colloid is a heterogeneous mixture which consists of, as we discussed, dispersion phase and dispersion medium. And the particle size should ranges from 1 to 1000 nanometer. So this is the most important point, the particle size. The particle size should be ranges from 1 to 1000 nanometer, and the substance it should contains dispersion phase and dispersion medium. This substance is also known as colloids. There are various sizes of the particles are there as follows. If we can consider a small colloidal particle, then the size will be less than 0.01 microns, and if the medium size means the medium size is 5 to 1, and if you consider the molecule or the particle is larger size, then that should be ranges from 10 to 1000 nanometers. So as we discussed, this colloidal contains dispersion phase and dispersion medium. So based on that, this dispersion phase is also known as discontinuous phase, and the dispersion medium is also known as continuous phase. An ideal colloids can be considered as a substance which lies between a true solution and a suspension. So we can understand about the colloidal solution or colloidal substance. This substance should be ranged in between a solution and a true. An ideal colloid should be ranges in between a true solution and a suspension. So this can be also considered as colloidal system. For example, we can take an acacia, insulin, albumin. So based on their particle sizes, especially in the particle size of the dispersion phase. So based on that only we can consider the examples like acacia, insulin, albumin will be an examples like colloidal solutions. As we discussed, here this is a colloidal system, and this should ranges in between a true solution and a suspension. So the true solution, here we have the suspension. So if you are considering the size, the true solution size, particle size should be less than 1 nanometer, and the suspension size is more than 1000 nanometer. But whereas coming to the colloidal solution or colloidal system, the size is ranges in between 1 to 1000 nanometer. You need to note down this. It is very important one, the particle size of the colloidal solution. You can see in the diagram. So this is the suspension and this is the colloidal solution and this is a true solution. So in between this true solution and in the suspension, here we have colloidal system or colloidal solution. Coming to the dispersed system. Dispersed system is a substance which contains dispersion phase and dispersion medium is called as dispersion system. So we can say this dispersion system is DP, that is dispersion phase, and DM, that is dispersion medium. So here you need to observe one thing, that we are not going to consider the particle size. Okay, so we are avoiding the particle size and we are considering biphasic phases. By means two different phases, that is dispersion phase and dispersion medium. So this system, the combination of the dispersion phase and dispersion medium is considered as dispersed system. Examples: suspensions, emulsions, colloids. So suspension also contains two different phases, that is dispersion phase and dispersion medium. Yes, of course, dispersion phase is known as discontinuous phase and dispersion medium is also known as continuous phase. In case of emulsions also, we will be having biphasic, by means two different phases, dispersion phase, dispersion medium. And in case of colloids also, we will be having dispersion phase, dispersion medium. So to talk orally, that means the dispersed system should contains dispersion phase, dispersion medium. So if you talk about this particularly particle size of this particular dispersion phase, then if the dispersion phase is ranges from 1 to 1000 nanometer of the particle size, then that is considered as colloidal substance. But here you need to understand that all dispersed system is not a colloid. Colloidal system is a part of dispersion system. The classification of dispersed system based on the size of the particle of dispersed system classified into three types as follows. The first class, that is monomolecular dispersed system, colloidal dispersed system, coarse dispersed system. This is the classification of dispersed system, and this is mainly based on the particle size of dispersion phase. So let us see the different types of the dispersed system. So here we have a table that indicating the property, and first type, that is monomolecular dispersed system, second type, that is colloidal dispersion system, third type is that is coarse dispersed system. So the first property, that is particle size. As we know, the colloidal dispersed system should have the particle size in between 1 to 1000 nanometer. And coming to this monomolecular dispersion system, the particle size should be less than 1 nanometer. And coming to this coarse dispersed system, the particle size should be more than 1000 nanometer. And coming to the second property, that is visibility, this monomolecular is not visible under electron microscope. Coming to the colloidal dispersion system, it is of course visible under electron microscope and ultra microscope as well. And coming to this coarse dispersed system, that is third type, it is also visible under electron and ultra microscopes. And the third property of this colloidal dispersion system, that is scattering of light. Scattering of light is also known as a Tyndall effect. So this monomolecular dispersion system does not scatter, means the particle will not receive the light which is emitted from a beam, and that is the reason we cannot find a Tyndall effect in case of monomolecular dispersed system. Whereas coming to this colloidal dispersion system and coarse dispersion system, yes, we can observe the Tyndall's effect in both coarse and colloidal dispersion system, and this is based on the particle size only, particle size. So if you have larger particle size, then we can emit the light. That means the light will get scattered from the particle. So that is the reason we can observe the Tyndall effect in case of both colloidal and coarse dispersed system. Coming to the fourth property, that is transport. So the monomolecular dispersed system will transports through the permeable membrane. Coming to this colloidal dispersion system, through impermeable membrane, and coming to the coarse dispersed system also through impermeable membrane. So this is also based on the particle size. And another property, that is settling, or you can say sedimentation, So coming to this monomolecular, there is no settlement, like there is no settling, does not settles. And coming to this colloidal system, it will settles, depends on the density. If density increases, then they will settles down and they will form some precipitations. And again, coming to this coarse dispersed system, it will settles. This also depends on the density. Coming to diffusion. Here in case of monomolecular dispersed system, you can observe rapid diffusion, and in case of this both colloidal dispersion system and coarse dispersion system, we will be have very less or a very slow diffusion rate. This is about the classification of dispersed system. Next, we will discuss about the classification of colloids. This classification of colloids is based on two things. First type, based on dispersed phase and dispersed medium, and second one, based on the nature of interaction between dispersed phase and dispersed medium. Let us discuss about the first type, that is based on dispersed phase and dispersed medium. So this based on dispersed phase and dispersion medium, so this class is mainly depends on the states of matter. So already we know that there are mainly three different types of states of matter, that is solid, liquid and gas. Based on these three states of matter, this classification is considered. In this, we'll be having different types of the colloids. So first, here, if dispersed phase is solid and dispersion medium is also solid, then this type of colloidal solution is known as solid salt type of colloidal solution. And the example for this gemstones we can consider. And if dispersion phase is solid and dispersion medium is liquid, then this type of colloid is known as salt type of colloidal solution. The examples are glue, gum and starch. Similarly, the solid as a dispersion phase and gas is dispersion medium, then this type of colloidal solution is solid aerosol, and the example is dust. Now, coming to the second states of matter, that is liquid, and in this always this liquid will act as dispersion phase, and now dispersion phase is liquid and dispersion medium is solid, then that type of colloid is known as gel type of colloid, and the examples are butter, cheese. Similarly, liquid and liquid both dispersion phase and dispersion medium, then this type of substance is known as emulsion, and the examples like milk. And dispersion phase is liquid, dispersion medium is gas, then this type of colloidal solution is considered as aerosol, and aerosol example is fog. And coming to the third states of matter, that is gas. So in this type, always this gas will act as dispersion phase, and solid and liquid will be two different dispersion mediums. So if dispersion phase is gas and dispersion medium is solid, then this type of colloid is known as solid form type colloid. And the example is pubic stone. Pubic stone is an example. And next, if the gas is dispersion phase and liquid is dispersion medium, then this type of colloid is known as foam. Example is shaving foam. This is about the classification of colloids based on dispersion phase and dispersion medium. And you should remember one thing, that dispersion phase and dispersion medium, this class is mainly depends on the states of matter. The second class, that is based on nature of interaction between dispersed phase and dispersed medium. So this second class is again divided into three main types. As usually, the first type, that is lyophilic colloids. Second type, that is lyophobic colloids. Third one is association colloids. So let us discuss one by one in detail. So first type of second class, that is lyophilic colloids. These lyophilic colloids also known as intrinsic colloids, and this colloidal solution in which dispersed phase or other particles have very strong affinity with liquid or dispersion medium. So in case of the dispersion phase, dispersed particles will be having more affinity to bind towards the dispersion medium. This type of colloids are known as lyophilic colloids. Lyophilic colloids, and also known as intrinsic colloids. If dispersion phase is able to disperse easily in dispersion medium, is also known as lyophilic colloids. You need to remember one thing, that is always these lyophilic colloids are reversible colloids. These are stable in nature, no required of stabilizing agents. Examples: starch and proteins. So this will be the lyophilic colloidal structure. So lyophilic means, as from the concept of the surfactant, lyo means lipids or oils. So this will be binds always with the oil phase, when oil phase is acts as dispersion medium, and then this lyophobic will be acts as dispersion phase. Second type, that is lyophobic colloids. So these also known as extrinsic colloids. These are the colloids are the colloidal solution in which the dispersed phase has very little affinity, of the dispersion medium. That means this dispersion phase, if dispersion phase has very low affinity towards binding with the dispersion medium, this type of colloid is known as lyophobic colloid. Whereas in case of lyophilic colloids, there we have the affinity is very strong in between dispersion phase and dispersion medium. But where is coming to this lyophobic, the affinity of binding in between dispersion phase and dispersion medium is very less. This type of colloids are known as lyophobic colloids. In this type, dispersion phase has no proper dispersion in DM, that is dispersion medium. They are unstable and they required stabilizing agents to make them stable. Third class, association colloids. The association colloids means the molecules or ions have affinity for both polar and non-polar solvent, is known as association colloids. The association colloids will binds with both portions like polar and non-polar. This polar is hydrophilic, this is lipophilic. This type of colloids considered as association colloids. The examples are SLS, sodium lauryl sulfate, cetyl trimethyl ammonium bromide. These are the best example for association colloids, and these are again divided into four types. First type, that is anionic colloids. So as we know, anionic colloid means they will be contains negative charged. Cationic colloids, positive charged. Non-ionic colloids, they may contains no charge. That means there is no positive charge and there is no negative charge. There is no positive charge, no negative charge. That type of colloids are known as non-ionic colloids. And fourth one, amphiolitic colloids. This type of colloids will contains both charges, positive and negative charges. The association colloids may form aggregation at different concentration, which is called as micelles. So micelles will form. There are chances to form an aggregations because the association colloids has no proper charges. So this depends on the dispersion medium and dispersion phases charges. So if the particles will get associated together and they may form a layer like structure, and that is called as micelle. At low concentration in water, the surfactant exists monomers and forms a loose layer, is known as aggregation of colloids, which is shown as in the figure. So this will be happens at very low temperature, at very low concentration. At high concentration in water, the surfactant exists as a monomer and forms strong layer, as known as aggregation of colloids. So here at high concentration, these colloids will be forms a strong layer, and this strong layer is known as micelle. The concept of CMC. CMC is known as critical micellar concentration. The concentration range of a surfactant at which micelles starts forming is known as CMC, critical micellar concentration. That means if any surfactant that will form a group or a layer like structure at particular concentration, this group or this layer like structure is known as CMC. The molecules are ion which have both polar and non-polars in solvent. The hydrocarbon chain will be considered as head portion, and the non-polar will be considered as tail portion. So here we can see the CMC. So this, as we discussed in the concept of surfactant, this will be considered as head portion, hydrophilic, also known as polar portion, and this will be the lipophilic or hydrophobic. This is considered as non-polar tail. This will be happens at very low concentration. If we maintain some proper concentration or constant concentration to this surfactants, they will be forming a strong layer like structure, which is known as micelle, and the concentration at which the micelle is formed, that is known as CMC, critical micellar concentration. Kreft point. So the Kreft point is also an important parameter, and this Kreft point is known as the temperature at which the solubility of surfactant is equals to CMC. That is known as Kreft point. So that means the solubility of surfactant should equals to CMC at proper temperature. This factor temperature is considered as Kreft point. As per this Kreft point, the solubility of the surfactant is depends on the temperature. Yes. So as per this Kreft point, the temperature will be deciding factor to the solubility of the surfactant, and when the solubility of surfactant is done, then they will form some group like structure which is called as micelles, and this micelles will be formed at a proper concentration, and that phenomenon is known as CMC, that is critical micellar concentration. So here you can observe in this graph, so on y-axis we can take a concentration and x-axis we can take the temperature. So CMC at this point, so CMC will be formed by means at this concentration the CMC has been formed, and solubility also increased when we are maintained proper temperature. So at this joining point will be considered as Kraft point. Coming to the applications of colloids, these colloids will be having various roles in the pharmaceutical industries, like they will be improving the solubility of drugs. Yes, of course the colloids will be improve the solubility of drugs. Some of the colloids are used for better therapeutic actions like anti-cancer treatments, to improve the absorption, to improve the stability of drugs, for targeting of drugs to specific organs. By means the colloidal dosage form will be targets the particular organ's target site, and this will be used as parenteral route of administration. This is the easiest route to administer the drugs. And thank you very much, hope you understood.
Like, share and subscribe. Hit the bell icon for more updates.